Sophie Karler from Jerncontoret. Sophie is going to present on water and resource efficiency in the steel industry and current challenges and new solutions under an ecosystem perspective. We chat with this about this yesterday, which I found super interesting. Sophie, you there?
Yes, I'm here. Thank you. Good morning, everybody.
Neil did a good job at staying at 5 minutes. The challenge is all yours now. See you in a minute.
Thank you. So I guess I will get the slides coming up, right? Good morning again. My name is Sophie Karler and I work for the Swedish Steel Producers Association. So I'm coming in from a little bit from the outside in this project. Thank you very much for the invitation. And I have had the privilege to follow this very exciting project from the outside during these years. Sandvik is one of our member companies and is part of the project. So let me first go through a few facts on the steel industry that I find necessary to understand the link between steel production and water, just in general terms. Steel has two possible ways of production. One is through blast furnaces, so-called integrated route, where iron ore is reduced at high temperature, with, of course, emissions of CO2. The other way is through melting scrap in an electric furnace. Both routes are used today and necessary at the moment. But either way, production processes are carried out at very high temperature, and water is the cooling medium used. It's important also to know that water affects the final quality of the steel, depending, for example, on the speed of cooling. In terms of water consumption, we're talking about approximately 10% of the intake of water that is actually consumed in the process through, for example, evaporation. 90% then being returned back to source. Some of it uncontaminated in the case of indirect cooling. And then there is another part of the water intake that goes directly into the steel making process and is therefore clean before return. So steel industry needs large amounts of water of good quality. And as you can see here, both quality and quantity then of water matters to us. Okay, I was a bit quick there. As you can see here, the steel producing plants are located by the water, very close to the water, be it rivers, lakes, coastal water, because water is of course a means of transportation. It's a means for cooling, as I was saying before, for steel making processes, and historically it was actually an energy supply through the water power, which is the reason why they're here. This is of course 4 plants in Sweden. So to us, water constitutes a critical ecosystem service for the steel industry, and we have shown this in previous analysis carried out on site. For example, ecosystem services review that have been carried out on different sites. This means that steel industry is both dependent and affecting the surrounding water. So I've asked our member companies to describe what they see as main challenges within water management today. And these are some examples. My conclusion is that the challenge is about resource efficiency altogether, be it economical, technical, regulatory, or a combination of these. So to continue allocating resources for expensive water treatment techniques when it's time to shift technique towards a fossil-free steel production, such as the hybrid project in Sweden, that is certainly an economical challenge. We also have new infrastructure to build, for example, to obtain a better environmental performance. That may be difficult or even impossible on old industrial sites that are already designed in a certain way, because we're not talking greenfield sites here, of course. So this is definitely a technical challenge. Another thing is that costs can be disproportionate in relation to the benefits. For example, in the case of wanting to further decrease the concentration of one single parameter in the surface water where you actually emit, while the overall quality of that water is not significantly changed. So this makes it difficult to comply with a regulatory framework that does not take into account the overall water quality. So this to us is a regulatory challenge, and we can get back to that in the discussion. This regards, of course, the Water Framework Directive. On a larger scale then, climate change, of course, affects both water quantity and water quality. And that is, of course, the top challenge. The hardest thing also to predict and where we know the least. So I describe this as a challenge on its own, and here again I would like to come back within the discussion to talk more about it. So given this situation, we see that we need to think outside the box for sure. Otherwise we'll never improve our current toolbox significantly enough. We need to work at different levels, and we need to shift the perspective towards a more ecosystemic perspective. We also need to use more nature-based solutions. A quick tour here in the next slide of examples that I've seen in the Swedish steel industry are top left of the slide, Höganäs AB creating a wetland in the south of Sweden on top of a closed landfill, adding water to an agricultural landscape with basically no water, increasing biodiversity and partnering up with local authorities in the work. Top right of the slide, SSAB in the middle of Sweden, Oxelösund, using a measure to decrease the emissions of nitrogen that they have from the blast furnace. They do this by restoring a lake to 100% functioning lake with the predating northern pike, that is the fish, coming back to spawn here in this lake, and thereby releasing the nitrogen sink in the lake and contributing to less eutrophication. And this was done in partnership with the sports fishermen of the region. The lower part of the slide, you have two pictures depicting another company and its byproducts to the left. Those it's a type of slags. And these slags are used in a cleaning water system to remove metals and phosphorus by creating this water purification solution. And it can be used at the moment for stormwater, for roads, spill off water from roads, and water wells, and there are more examples than that.
Sophie, can I stop you there?
Yeah.
And we'll try and come back to finish on the other topics in a few moments. Thank you.